Hello everybody. In this video we are going to look at the solutions to the college prep waves and vibrations due right now number 2. Scared Emmy over there. Love it. Can't scare you guys, but I can scare the heck out of my own daughter, so that's not too bad. All right, let's take a look and see what the first problem is asking. Says if the frequency of oscillation of the wave emitted by an FM radio station is 88.0 megahertz, determine A, the wave's period of vibration, and B, its wavelength. And we're told that radio waves will travel at the speed of light, which is 3.00 times 10 to the 8th meters per second. So we know the frequency of the wavelength, or the sound wave, the radio wave, I should say. The frequency of the radio wave is 88.0 megahertz. The Greek or the metric prefix mega is 10 to the 6th. So we have to convert that to hertz. So 88.0 megahertz is going to equal 88.0 times 10 to the 6th hertz. To find the period, I know I just take the reciprocal of the frequency, so I just take 1 and I divide that by our frequency. So the period is equal to 1 over 88.0 times 10 to the 6th hertz, and that will give me a period of 1.14 times 10 to the minus 8th seconds. Now to find the wavelength, I know that I have to use my wave speed formula, V equals F times lambda. Remember, lambda is my variable for wave speed. I want to solve this for lambda, so lambda is going to equal V divided by F. My velocity is the speed of light, 3.00 times 10 to the 8th meters per second. Divide that by my frequency of 88.0 times 10 to the 6th hertz. And I'm going to have a wavelength of that radio wave of 3.41 meters. Problem 2. The distance between two successive crests of a transverse wave is 120 centimeters. 8 crests pass a given point every 12.0 seconds. Calculate the wave speed. So I know that the wavelength, which is the distance between two crests, is 120 centimeters. Converting that to meters will give me 1.2 meters. And I know that there are 8 crests, or 8 oscillations, every 12 seconds. So my frequency is the number of oscillations per second. So I have 8 crests or oscillations in 12 seconds. So 8 divided by 12 is going to give me 0.67 hertz. Once again, in order to calculate the frequency, I know I need my time component in the denominator because my hertz is equal to 1 over seconds, or seconds to the minus 1. So that's a good way to tell which way to set things up for frequency, and it would be the opposite for the period. But for frequency, I need my time value in the denominator. And we are being asked to find the wave speed. So to find the speed of the wave, I know that I have to multiply the frequency times the wavelength. So the frequency of 0.67 hertz times my wavelength of 1.2 meters is going to give me a wave speed of 0.80 meters per second.